Good afternoon, everyone. My name is Aranya Chakraborty. I'm a program director in the National Science Foundation. And in this presentation, I'm going to describe some of the ongoing research activities that we are doing at NSF in the areas of power control and also cyber physical systems. And I'm making this presentation on behalf of my other colleagues in the power, energy, and control area, including Dr. Donald Wunsch, who works in machine learning and data science, Dr. Iyad Abed, who works in controls and power, and Dr. Mahesh Krishnamurthy, who works in power electronics and electric machines and energy conversion. So, just a little bit of a history about National Science Foundation and its mission. So, NSF is an independent federal agency which was established by the US Congress in 1950. And the aim of NSF is to promote the progress of science and also to advance national health, prosperity, and welfare, as well as to secure national defense and security priorities. Also, NSF is the only federal agency whose mission includes the support for all fields of fundamental science as well as for engineering. So we focus on both science and engineering, unlike many of the other federal agencies who are only devoted to scientific activities only. The structure of NSF is very much similar to that of a university. For example, within the engineering directorate, we have our assistant director, Dr. Don Tilbury, and then under the AD's office, we have these different divisions, or which are equivalent to departments. And some of the divisions, they are listed over here, like including chemical, bioengineering, and environmental systems, which is CBET. Then we have civil, mechanical, and manufacturing, which is in CMMI. I specifically belong to electrical communications and cyber systems, or the ECCS division, which handles all topics related to electrical engineering. And then aside from that, we also have the engineering research centers and the industrial innovation and partnerships, which supports SBIR and small business and small translational research type of grants. Now, within the ECCS division, ECCS stands for Electrical Communications and Cyber Systems, as I mentioned. So, within the ECCS division, we have three research clusters. These are also denoted by various acronyms. The cluster where I personally belong to is the Energy, Power, Controls, and Networks, which is abbreviated as EPCN. Aside from EPCN, we also have two other clusters, namely Communications Circuits and Sensing Systems, or CCSS, and Electronics, Photonics, and Magnetic Devices, or EPMD. Now, in all of these clusters, the career program is one of our most fundamental, and it's our highest or the biggest investment that we make is through actually the career programs, because we are extremely devoted to advancing the careers of our young PIs, or the junior PIs, who are going to make a substantial amount of difference in next generation research in their respective fields. Now, specifically in the EPCN cluster, we have three different thrusts, actually four different thrusts, namely the control thrust, then power system thrust, then we have machine learning and data science thrust, and then we also have power electronics and electric machines and energy conversion thrust. So within the control system thrust, we deal with different fundamental ideas of control theory, including robust control, optimal control, nonlinear and adaptive control. Lately, we have also been spending a lot of efforts, and we have been funding quite a few research initiatives on data-driven control, and also the applications of reinforcement learning and deep learning in control theory. Network systems and control of multi-agent networks in extreme scales. These are some fundamental topics which have always been of interest to our controls program. And of course, with the emergence of cyber-physical systems, we are also focusing a lot on reliability, safety, cybersecurity, and usability of different kinds of control systems. Within the power system thrust, there's a lot of push right now on topics which are relevant to climate change, especially the integration of large amounts of renewable energy such as wind power and solar power, and how all of these new sources of energy can be used in the transmission grids, distribution grids, as well as in microgrids. We also fund a lot of research on new concepts of electricity markets, such as changing demand profiles and consumer expectations, and the need for resilient grid operations using power electronic devices, for example, in the face of extreme events such as natural disasters or superstorms and hurricanes. From a cyber physical system perspective, we also fund a lot of research which has to do with the application of sensing, communication, and information technologies in the control of power grids in both transmission and distribution scales. We are also funding quite a bit of research on real-time decision making and massive data analytics, the application of all of these massive data analytics techniques in power system networks. Cybersecurity of power system is a perennial topic of interest to us, and then lately we are also focusing a lot on new ideas of how power electronic converters can be integrated with power system dynamics, and how power electronics plays an important role in stability and dynamical performance of traditional power systems. In the machine learning and data science cluster, we have various topics of interest, including neural networks, neuromorphic engineering, data analytics, machine learning hardware, traditional machine learning algorithms, analysis and applications, and also human machine interaction, as well as trust and cybersecurity issues in all of these subtopics. The NSF 10 Big Ideas is something which started a few years ago, which is a list of grand challenges that has to happen over the next decade, for example, and which is going to change the way of life, which is going to change the way society works in this country, in terms of both research ideas as well as implementation or infrastructural ideas. So among the research ideas in this list of 10 big ideas, one of the main ideas is the harnessing the data revolution, which is often abbreviated as HDR, and that has to do with how new methods of machine learning, deep learning, reinforcement learning, and all of these novel supervised and unsupervised learning, and their associated associations with control theory and real time decision making, human machine interaction, and all of those new ideas which pertain to harnessing the data revolution. All of those ideas actually fall within the HDR initiative in terms of both research and education and workforce development. Some of the other ongoing research ideas within this list are, for example, the quantum leap and application of control theory in quantum leap is also of interest. And also, like for example, the future of work, or work at the human technology frontier, which will shape the future of workforce development and how human beings will work in various layers of the society. So all of these new ideas are being paid attention to within the NSF 10 Big Ideas list. Among the infrastructural projects which we are dealing with, one of the main ideas is the mid-scale research infrastructure, and I'll mention just a quick comment about that in just a second. But here again, the idea is to develop a large-scale infrastructure which is going to be of societal use, grand challenges of societal use for the next generation of our society. Now, aside from the core programs, ECCS also participates in a bunch of um, other external programs. One of the main ones is the CyberPhysical System, which is driven by the SIZE Directorate. And again, so the fundamental idea of cyber-physical system is that you have these different physical processes which define the application sectors, for example, and then you have these cyber layers in your system which may be needed for real-time decision making and control, and then there's these different information technologies and different communication technologies that will be used within the cyber layer. And the whole idea is that how do these cyber frameworks and the physical frameworks interact with each other in terms of both open loop and closed loop decision making. CPS, of course, is also co-funded by several other agencies such as the Department of Transportation, because transportation CPS is a very important sector of the CPS program, also with the National Institute of Health and the Department of Homeland Security, which funds a lot of research on cybersecurity and privacy and the issues of trustworthiness. Besides CPS, ECCS also participates in the Smart and Connected Communities program, or SNCC. And here the idea is that the researchers have to engage in cutting edge research topics which are of interest to specific communities. So they have to have a very strong community engagement plan where they're going to interact with members of that community and carry out the research which will enhance the quality of life for that community. So usually these are slightly bigger scale proposals where engineers are supposed to team up with social scientists and also computer scientists and solve a societal level problem which is going to make a big impact, a very broad impact on the specific community of their choices. Another relatively new program which we are participating in, and this is actually led by the CBET division. It's The name of this program is called the Sustainable Regional Systems, or SRS, and the idea over here is that uh, how do big cities as well as small villages interact with respect to each other in terms of satisfying each other's daily societal needs. For example, big cities are dependent on the rural areas or small villages in terms of agriculture and irrigation, while the smaller villages are dependent on the bigger cities for electricity, for transportation, for economic flows, and things like that. And what the SRS program is trying to capture is how do these interactions happen, how do you close the loop from one infrastructure to another, and how you can develop different socioeconomic principles by which the closed loop interaction between different regional systems can be made more efficient, can be made more sustainable. So again, so these are also slightly bigger team efforts, but transportation and energy are definitely two of the main interests of the SRS program. So that's why I think it's worth mentioning to this audience, because this may be of interest to some of you who, especially those of you who work in applications of control theory in power systems as well as in transportation. Within the ECCS division, we about 2 years ago we started a new special solicitation within our division called Ascent, and Ascent stands for Addressing System Challenges Through Engineering Teams. And here the idea is that I mentioned about the three clusters within the ECCS division. And the idea over here is that even within the clusters, the research can sometimes become a little bit too decentralized. For example, people who work on electric power and controls, they often do not communicate or do not talk very closely to people who work in energy harvesting and data management, communications and computing or sensing, or even with device level research such as in photonics and magnetics and material science type of ideas. But there can still be very pertinent and pressing problems at the intersection of these subfields of electrical engineering, and that's why we created the Ascent program, so that we can bring the sub communities within the electrical engineering, broad fields of electrical engineering, closer to each other in terms of their collaborative nature. Also, there are, as I mentioned, among the NSF big ideas, HDR is one of the main driving ideas, and within the HDR program, we have also various, branching topics such as the mathematics of deep learning, or MODL, as well as the AI Institute. Now, MODL, for example, is trying to bring researchers in control theory and mathematics and statistics and computer scientists as well as social scientists close to each other for solving various fundamental problems that are of seminal use to deep learning and neuromorphic computing and neural networks and various implications or applications of neural networks, and how deep learning can be made much more efficient and safe and trustworthy. So some of the keywords of interest to the controls community for the MODL program are control theory, formal methods, data privacy, cybersecurity, and other CPS centric topics. So I would strongly encourage all the people who work in control theory and are interested in mathematics of deep learning. They should definitely take a look at the MODL program, and because this year's deadline is passed, but maybe you can plan for next year's program, because these are medium scale awards where you have to have engineering, mathematics or statistics, and computer scientists in the team, and then it's optional to have a social scientist in the team as well. Then the final program which I wanted to draw your attention to, which I thought may be of interest to this audience, is the so-called mid-scale research infrastructure 1 and mid-scale research infrastructure 2 programs. Again, so these are infrastructural solicitations and not exactly research solicitations. Here the idea is to develop actual physical infrastructures, and so the focus is more on actual constructions and implementation rather than just pen and paper fundamental research. And the funding range for the mid-scale programs are on the higher side. For example, mid-scale 1 is between $6 and $20 million, while mid-scale 2 is between 20 million and $100 million. And one of the mid-scale 2 awards was actually recently given to UC San Diego for creating a nationwide testbed on microgrids, and also showcase how power electronic converters, the integration of renewables and power electronic converters, how they are going to affect stability properties of the current conventional grid. So they are going to a $40 million award was made to UC San Diego to develop a campus-wide test bed, where other universities or other national labs can use that test bed after it is implemented. Other national labs and other university and other research labs can use that test bed to carry out different kinds of experimentations related to power grids and renewable integration for the future. So that is pretty much all I wanted to say. And if there are any other questions about our programs at NSF, or any specific program within the ECCS Electrical Communications and Cyber Systems Division, if there are any specific questions about the solicitations that we have, or if there are any specific questions about the career program in general, please feel free to reach out to me by email. I'm showing my email address over here. So I'm always very willing to receive emails from our junior PIs who may have some queries or questions about the career program. So if you do have any questions, feel free to reach out to me, and I'll get back to you at my earliest convenience. So thank you again for listening, and thanks again. Thanks.